Welcome back to Real Class. I remain Engineer Shegun. And today we'll be talking about dynamics. Dynamics is an aspect of physics or is a branch of physics that's concerned with force and as well as the motion that it can cause. In dynamics, force is very important. What is force? Well, force is simply a physical agency that can cause a change in the state of rest or motion of a body. And force basically is a product of mass times acceleration. We are going to see where this formula is coming from when we get to Newton's second law of motion. What are the types of force? From our everyday experience and in the universe generally, there are two types of force. There is contact force and there is non-contact force. Contact force are those forces that requires contact between two surfaces for them to act. So for example, friction is a contact force. Tension is a contact force. Reactions are contact force. Tension is a contact force. You can even say the force of pull and push. All of these are examples of contact force. Non-contact force. Non-contact force are those forces that do not require the contact of surfaces for them to act. Examples of non-contact force are like gravity. Gravitational force is a non-contact force. Magnetic force is a non-contact force. Electrostatic force is a non-contact force. Nuclear weak and strong nuclear forces are examples of non-contact force. Now that we have talked about contact force, Newton's laws of motion is a very important concept that we need to talk about. What are the Newton's laws of motion? There are three of them. There's Newton's first law of motion, there's Newton's second law of motion, and there's Newton's third law of motion. What does Newton's first law of motion state? Newton's first law of motion states that a body at rest will continue to remain at rest, and a body moving along a straight line with a constant speed will remain in that state unless being acted upon by an external force or an unbalanced force. That's Newton's first law. It simply means that a body that is at rest would not want to move, would not move, and a body that is already moving will not want to stop. For you to cause a body that is stationary to move, you need to apply a force. And for you to cause a body that is already moving to stop, you need to apply a force. Remember I said moving along a straight line with a constant speed. So it also means that if you want to even change the direction, you also need to apply a force. If you want to increase the velocity, cause it to accelerate, you also need to apply a force. Hence, we can say that there's a reluctance to motion for a body that is at rest, and there's a reluctance to stopping for a body that is already in motion. This reluctance of a body to either stop moving when it's already in motion or to start moving when it's at rest is known as inertia. This is the spelling. Inertia. This property of a body is associated to mass, just like every other thing, just like every other quantities or quantities are associated to mass. So inertia is associated to mass and is dependent on the mass of a body, which means that the more massive a body, the more mass a body has, the more inertia it will have. The more mass a body has, the more it is harder to stop it when it's already moving. The more mass a body has, the more it is hard for you to make it move if it's at rest. Inertia is dependent on mass. That is the reason why Newton's first law is also known as the law of inertia. Now that we have talked about Newton's first law, let's talk about Newton's second law. Newton's second law simply states that the force applied to a body is directly proportional to the rate of change of momentum with time. In other words, I can say that force F is directly proportional to the rate of change of momentum with time. If the rate of change of momentum with time is I, the force will be I. Now, if I were to remove this proportionality sign, I will introduce a constant. The constant, we chose the constant to have a magnitude of 1. Therefore, F is equal to a change in momentum over time. But what is the change in momentum? The change in momentum is mass times change in velocity. So I can actually say that the change in momentum P is equals to mass change in velocity. What is momentum basically? Momentum on its own P is equals to mass times velocity. But the change in momentum is mass into bracket final velocity minus initial velocity. That is the change in momentum. If I were to plug this back into this place, I would have force is equals to m into v minus u close bracket t. And from here, if I cross multiply, I would have ft is equal to m into bracket v minus u. This is t. This is force times time, and force times time is a quantity known as impulse. Impulse is the product of force and time, or it is the time to take the force to act on a surface. The product of the force and the time it takes the force to act on a surface. So this is a very important concept we need to take note of. I is equals to change in momentum. Still coming back to this equation, if you check this very well, v minus u over 2 is acceleration, change of velocity with time. So I can also say from this one to that force is a product of mass and acceleration. If force is a product of mass and acceleration, it becomes important that there is no force without acceleration. If there is no acceleration, then there is no force. This A also can be mean deceleration. Deceleration is just negative acceleration. The next thing I would like us to consider is is Newton's third law of motion. We have looked at first law, we have looked at second law. Now let's talk about the third law of motion. Newton's third law of motion is extremely easy. Newton's third law of motion says that to every action there is an equal and opposite reaction, which can also be simply put as action and reaction are equal. It simply means that if I hit this board with my palm very hard, I'm going to feel pains on my palm. The pain I'm feeling on my palm is because I've applied a force on this board, and naturally the board should also exert an opposite force to my hand. Similarly, the reason why we can swim is still because of Newton's third law of motion. If you are swimming and you pull water backwards, you equally move forward, because to every action there's an opposite and equal reaction. Rocket propulsion is also based on Newton's third law of motion. If a rocket wants to take off, it ejects a very large amount of hot gas. As that gas goes down, the rocket goes up. Action and reaction are equal and opposite. Now, the word normal reaction, the word normal in mathematics, normal means perpendicular. So, normal reaction is a reaction that is perpendicular to the surface. From Newton's third law of motion, we can also explain the concept of recoil velocity of a gun. Recoil velocity of a gun. For a soldier shooting a gun or a policeman shooting a gun, depending on the type of gun, but in any of this type, it will experience a jerking back as it pulls the trigger. The reason for that is this: as there's an explosion inside the gun, of course the gunpowder, the bullet is being eject out of the gun forward. There will be an opposite reaction on the man. So that is why to every action, there's an equal and opposite reaction. Therefore, let's say the force of the gun, let it be Fg, and the force of the bullet, let it be Fb. Since both of them were initially at rest, their initial velocities will be equal to 0. So I can say force is mass times acceleration, or force is equal to rate of change in momentum over time. Although the rate of change in momentum is mv minus m into bracket v minus u. There is no need to put u there because both of them were initially at rest. Both the gun and the bullet, before the trigger was pulled, they were both initially at rest. So u is equal to 0. So now I will say the mass of the gun, the final velocity of the gun, divided by time will be equal to mass of the bullet, final velocity of the bullet, divided by time. Both of them, this whole explosion occurred at the same time. So the time here and the time here will be the same. If so, they are going to cancel out. And once they cancel out, I'm going to have that mass of gun, velocity of gun is equal to mass of bullet, velocity of bullet. This velocity of the gun is known as the recoil velocity of the gun. And this is the velocity of the bullet. So if you are asked to find the recoil velocity of the gun, is Vg, and you can make Vg subject of formula. Let's also consider a body moving in an elevator. A body in an elevator, or simply put, a body in a lift. There are several categories I want to look at this. You can be in a lift and the lift is not accelerating. It's not even moving at all. You can be in a lift that is going either upward with a constant speed or moving downward with a constant speed. You can be in a lift that is accelerating vertically upward. You can be in a lift or elevator that's accelerating downward. What will happen to your weight or to your normal reaction, to your apparent weight, your normal reaction, or the reading of a scale when you are in these situations? For the first situation, for the elevator that is stationary, the normal reaction you are going to experience on it will be equal to your actual weight. Which means, if you were to take your weight in an elevator that is stationary, the reading you are going to get is your actual weight. Also, if the elevator is moving up or down, with constant speed, or velocity, you are still going to weigh your actual weight. The normal reaction you are going to experience, the tension on the cable, will still be equal to your weight or the weight of the elevator, depending on how the question is framed. So R will still be equal to mg, where R is the reading, your apparent weight, the tension on the string. Now, what if the elevator is not accelerating upwards, or what if the elevator is accelerating downwards? For elevator accelerating upwards or downwards, let's first consider the elevator accelerating upwards. Now, for elevator accelerating upwards, you will have arrow normal reaction to be equal to m into bracket g plus a, which means that for a body in an elevator that is accelerating upward, it's going to weigh more than the actual weight. So we are going to have r to be equal to m into bracket g plus a. Now, the next will be, what if the elevator was accelerating downwards? If the elevator was accelerating downwards, then for elevator accelerating downwards, we are going to have the normal reaction arrow. Remember I said that normal reaction is the apparent weight or the tension on the cable, depending on how the question is framed, will now be equals to n into bracket g minus a. Here, a is the acceleration of the elevator or of the lift. The same thing with this a here. But g here is the acceleration due to gravity. N are the masses. So if the elevator is accelerating downwards, you are weighing less And if it's accelerating upwards, you are weighing more than your actual weight. So the next thing we're going to look at now are some questions that has been asked on this. So still on dynamics, let's take our question. A force acting on a body causes a change in the momentum of a body from 2 kilogram meters per second to 16 kilogram meters per second in 0.2 seconds. Calculate the magnitude of the force. So we are asked to find the magnitude of this force here. What are we going to apply here? Newton's second law of motion. And Newton's second law of motion states that force F is equals to change in momentum over time. Now, the change in momentum is final momentum minus initial momentum. So I can say it's P2 minus P1 divided by time. This is change in momentum. I could have used M into bracket V minus U, but they didn't give us the velocities and the mass. They just gave us the momentum and the change. So this was the momentum it had before, and this is the momentum it's now having now. So the change in momentum is now equals to from 12 to 16, which will now be 16 minus 12 divided by, the time is 0.2 seconds, which is 0.2. From here, 16 minus 12 will give me 4 divided by 0.2. From here, I would have 4 divided by 0.2 will give me 20 Newton. So the force is 20 Newton, which is option B, because 20 is the same thing as 20.0. Now, let's take question number 2. Still on dynamics. This is our question number 2. When taking a penalty kick, a footballer applies a force of 30.0 Newton for a period of 0.05 seconds. Full stop. If the mass of the body is 0.0075 kilogram, calculate the speed with which the ball moves off. You're asked to find the speed with which the ball moves off. What are you going to do? Here they gave us time and they gave us force. And they're asking us for the speed with which it moves us off. I know that force times time is equal to change in momentum. This force times time is impulse, and this is change in momentum. So what is our force? Force is 30. What is the time? The time is 0.05 seconds, which is equal to the change in momentum. What is the change in momentum? It's going to be mass, and the mass there is 0.0075 into brackets. The change in velocity is final velocity minus initial velocity. The ball was initially at rest, so the initial velocity will be equal to 0. So I'm now having V minus 0. From here, if I were to do 0.05 times 30, I'm going to get 1.5. So here, I'm going to have 1.5 is equal to 0.0075 V, because V minus 0 will give me V. This is the same thing as writing 0.0075 V is equal to 1.5. Divide both sides by 0.0075. So V is equal to 1.5 over 0.0075. This will be equal to 1.5 over 0.0075. This is going to give me 200 meters per second. That will be our answer. So in our next class, we are going to look at other concepts.